You know all this incredible AI stuff we're seeing? ChatGPT, Sora, the magic that makes Google search just work? It feels like it all just exploded out of nowhere, right? Well, what if I told you that almost all of it, the whole shebang, can be traced back to one single research paper from just a few years ago? Let's dig into how one document literally changed our world.
So yeah, that's the big question we're tackling. How did this one paper from a small team at Google manage to light the fuse for the entire AI revolution? We're not talking about a small improvement here. This paper didn't just nudge things forward, it completely rewrote the rules and unleashed the world we're all living in today.
And this is it, the paper itself. It's got this wonderfully quirky title, Attention is All You Need. A total nod to the Beatles, of course. It was written by a team of 8 scientists at Google. Now, this wasn't just another small update. This was the spark. But to really get why it was so revolutionary, we first have to understand what the world of AI looked like before this paper dropped.
Okay, so let's set the scene. Before 2017, AI had a huge problem. It was hitting a brick wall. It was trying to understand language in a way that seems logical to us humans, but for a computer, it was incredibly inefficient. You see, the models they used back then, like recurrent neural networks or RNNs, they read text sequentially. They'd process the first word, try to remember it, then move to the second, then the third, one by one. It makes total sense, right? That's exactly how we read. But for a computer, this linear process created some really serious problems.
This breaks it down perfectly. The old method, on the left here, was just plain slow. You couldn't even start on the 10th word until you were done with the 9th. These models also had a terrible memory. By the end of a long paragraph, they'd often forget what the beginning was even about. And maybe the biggest problem of all, this step-by-step approach was totally incompatible with modern hardware, like GPUs, which I designed to do a ton of things at once. It just couldn't scale up.
And this wasn't just a minor hiccup, it was a massive wall. You couldn't just throw more computing power at it to make the models bigger or smarter, because the very architecture, the design itself, was the bottleneck. AI was fundamentally stuck in the slow lane.
So how did the Google team get past this wall? Well, they didn't just try to improve the old method. They threw it out completely and replaced it with a powerful and honestly game-changing concept called attention.
To put it simply, an attention mechanism lets an AI model look at an entire sentence all at once and figure out which words are most important for understanding any other word. So, for example, in a sentence like, "The robot picked up the red ball because it was the only one on the floor," attention helps the model instantly understand that it refers to the ball, not the robot or the floor.
And this was the radical leap. Instead of going word by word, they asked, what if we just gave the model the entire sentence at once and let it figure out all the connections at the same time? This parallel approach was tailor-made for modern GPUs, and it completely shattered that sequential bottleneck.
But you have to realize, this idea flew in the face of everything the AI field believed at the time. The team of 8, who famously listed themselves as equal contributors to show it was a true team effort, they faced some intense skepticism. One author even mentioned that his own father, a well-known computational linguist, was pretty sure it wouldn't work. But Team Transformer, as they called themselves, they pushed ahead anyway.
So how did they actually make this look at everything at once idea work? It all came down to 3 really clever innovations that make up the core of what we now call the Transformers architecture.
First up, you've got self-attention, which is that core mechanism we just talked about. It lets the model weigh the relevance of all the other words for any single word it's looking at. Second, they created multi-head attention, which is like having a whole team of experts analyzing the sentence all at once. One head might focus on grammar, another on who's doing what to whom, and a third on the overall feeling or sentiment. It creates this incredibly rich understanding. And finally, there's positional encoding. Now, if you're not processing words in order, how do you know which one came first? This was a genius trick. They basically stamp each word with a unique mathematical signal that tells the model its exact position in the sentence.
And when you combine these 3 ideas, you get the transformer. It's an architecture that wasn't just smarter and better at understanding long-range context, it was also massively parallelizable. It was faster, it could be scaled up to incredible sizes, and it was about to change the world.
And change the world it did. The publication of this paper in 2017 wasn't just some academic success, it was the starting pistol for the AI race that we're all living through today.
The impact was immediate and just immense. As of right now, the paper has been cited over 173,000 times. That is an insane number.
It makes it one of the most influential scientific papers of the 21st century, period. It didn't just inspire a few new models, it became the foundational blueprint for an entire field.
This timeline just shows how fast everything exploded. The paper comes out in 2017. Just 1 year later, boom, Google releases BERT, and OpenAI releases the very first GPT model, both built using transformers. Fast forward to 2022, and ChatGPT brings this power to millions of people. And now, that same core idea is powering AI that can understand and create images and even video like Sora. The line from that 2017 paper to the tools you use today is direct and unbroken.
And it is truly everywhere. When Google search just gets what you really mean, that's a transformer. When you're having a conversation with ChatGPT, that's a transformer. When you use DALL-E or Sora to generate an image from a prompt, yep, you are interacting with a direct descendant of the transformer architecture.
So what happened to the 8 authors who started it all? This part of the story is fascinating. Every single one of them has since left Google. They've all gone on to found their own incredibly successful AI companies like Cohere and Character.ai. It's like they built this revolutionary engine inside Google and then left to build the next generation of cars, feeling they could innovate faster on their own.
So, here's the crucial takeaway. Attention is all you need did more than just introduce a new model. It gave the entire world a brand new, scalable, and unbelievably powerful recipe for building AI. It handed researchers the keys to unlock a level of performance that was pretty much unimaginable before.
And that leaves us with one final big thought. The transformer was born because a team dared to challenge a fundamental assumption that AI had to process language in order. They proved that looking at everything all at once was better. So the question for the future is, what deeply held belief about AI is just waiting to be overturned next? What will be the next attention is all you need?